We have an Excel file where we can reproduce and simulate the behavior of that very simple system. And I have two sheets here. I'm going to explain first how this, which I called one rep, works. We have a set of rows corresponding to 10 parts. We are going to simulate how we would produce and what are the times for 10 parts. Okay? And we have in blue information related to Bob, our first stage, and we have in this kind of brown information for Ray. Okay, and I'm going to focus first on these orange numbers, and then I will explain the rest. So let's take a look at this first part. We know that it takes some time that differs from Bob to Ray and from part to part to produce every single part. So let's imagine for a moment, I'll explain that later, that it took 50 seconds for Bob to work on that first part. And that means that if this is the first part we're producing, Bob will start working on it on time equals 0, and after 50 seconds, it'll be finished. So it'll be finished by the 50th second. We might know as well, and again, I will say how we can calculate that later, that the time for Ray to produce this first part is 60 seconds. So notice that Bob has to work on this part first. It finished at the second 50, and that will be the start time for Ray, because only when Bob has finished with that first part, Ray can start working on it. That means that Ray will start at second 50. It'll take him 70 seconds to work on it, and it'll finish at 120. And as a result of that, Ray has been waiting 50 seconds because that was the time from the very moment we started the production that he was waiting for Bob to finish the first part. Okay, let's go to the second part. Let's imagine that somehow we know that Bob is going to spend 50 minutes and Ray is going to spend 50 seconds, as well. So, since Bob finished working at time 50, he will be able to start at 50. Since it's going to take him 50 seconds to work on this second part, he'll be done by 100. But this end time is prior to the finishing time, to the end time for the first part of Ray. So he'll have to wait until Ray, is free from this first part. So he'll be waiting 20 seconds. So that when Ray finishes with first part, okay, at this time, Bob will take a third one. He'll start working on it at second 120 and we'll start with it. And then when Ray finishes with the first part, he'll be able to work on the second one, which is what we see here as the start time for the second part, which is 120. And since he's going to spend 50 seconds on it, he'll finish at 170. Okay, so what happens with the third part? Bob started working on it at 120. It'll take him 60 seconds to work on it. He'll finish at 180. Okay, and in this case, Bob is finishing later with his third part than Ray with the second one. So as soon as Bob finishes with this part, he will be able to pass it on to Ray, who will start working on it right at that very same time. Okay, and right after that, Bob will be able to work on the fourth part, and so on. So what we have here is the waiting times for Bob, because that corresponds to the moment where he finished his part and Ray hadn't finished working on the previous one. And here we have the waiting times corresponding to the moment where Ray has finished his work and is waiting for Bob to finish his. Okay? So what we can do now is to do some calculations. First, we can know that for these 10 parts, Bob has spent 470 seconds working on them. He's been waiting 60 seconds, okay? And the same we can do for Ray, okay? We have this total time, which is 430, and this is the waiting time. And this is the total time, okay, for producing the 10 parts. This is for 10-1, for part 1, for part 2, and second. So for that, we subtract the end time for Ray minus the start time for Bob, which is not exactly the summation of these two values. Sometimes that is the case, and sometimes that is not the case, okay? Because let's see an example. Okay, for example, for part 7, it took Bob 50 seconds to work on it, 20 seconds for Ray, but since there was this waiting time here, the total time for us since the moment we started to this part till the moment we finished it, it wasn't 50 plus 20, but 50 plus 20 plus these 30 seconds of waiting time. Okay, so that way we can calculate the average total time we spent on every part, which is 96. That's the result of this simulation. We can calculate the busy time per on average, okay, the same here, which is just dividing this by 10, and we can calculate the utilization rate, and we can divide the total time spent, which is 407 seconds, by the waiting time plus the working time. So in this case, Bob has been available, the summation of these times, okay, 530 seconds, and he's been only working this time. So if we do that division, we can get the utilization rate, and the same goes for Ray. We can do that math or that calculation, and we know how much time we're using productively out of Ray's time.